You haven't seen this treasure story anywhere else.
Veteran treasure hunters know that the most dangerous vaults are protected by pure mathematics rather than earth or stone. Today, a $60 million fortune remains hidden in America, guarded by an unbreakable 19th-century cryptographic barrier. This active anomaly is located within the rugged, densely forested valleys of Bedford County, Virginia. The historical data places the origin of this hoard in 1819. Thomas J. Beale and a company of 30 elite hunters traveled deep into the Western Territories, where they uncovered a high-grade hydrothermal vein of native gold and silver near Santa Fe. This chart displays the immense physical scale of their 18-month extraction. They processed 2,921 pounds of native gold and 5,492 pounds of pure silver, a volume of bullion that far exceeded the capacity of a standard supply wagon. Transporting nearly 4 tons of high-conductivity metal across lawless, untamed territory presented a lethal logistical hazard. The party hauled the treasure across the country to the iron-rich hills of Virginia. There, they excavated a subterranean vault and packed the bullion into reinforced, iron-lined containers. The extreme weight of the wealth created a permanent security risk. Because they could not guard the site in person, they developed a system to pass the vault's location to their heirs without exposing it to the public. In 1822, Beale added a physical layer of security by leaving a reinforced wooden chest with a trusted innkeeper in Lynchburg. He provided strict instructions to leave the chest undisturbed unless he failed to return within 10 years. Beale vanished back into the western wilderness and never returned to claim the box. After waiting 20 years, the innkeeper finally opened the chest, expecting to find a map or a property deed. The box contained 3 distinct sheets of paper covered in hundreds of numbers, the Beale Ciphers. Beale had moved his security away from the physical world and into a mathematical framework, creating a puzzle that has resisted analysis for over a century. These documents utilize a book cipher. In this method, numbers point to the first letter of specific words within a hidden master text. Following decades of failed attempts using Bibles and Shakespeare, an anonymous researcher tested the sequence against the absolute foundational document of American history. Breaking the code required numbering every single word of the Declaration of Independence sequentially, from 1 onward. This animation demonstrates the extraction process for Sheet 2. The cipher digit 115 corresponds to the 115th word of the Declaration, instituted. The decoder then extracts the first letter, I. The decoded message of sheet number 2 confirmed the vault's contents: 2,921 pounds of gold, over 5,000 pounds of silver, and jewels intended to insulate the core wealth. While sheet 2 validated the existence of the $60 million fortune, it purposefully withheld the data needed to find it. The final 2 sheets remain unbroken, acting as digital sentinels over the physical vault. Sheet number 1 consists of 496 individual digits. These numbers are believed to hold the geographic coordinates and topographic markers required for a physical recovery. Modern technology has reached a stalemate. AI pattern analyzers and supercomputers are ineffective against a book cipher because the security is rooted in a specific external text. Without the exact master text, which could be a private journal or an obscure local charter, the numbers remain mathematically unbreakable. Sheet number 3 remains similarly elusive, containing the list of 30 frontiersmen and their heirs who hold the legal claim to the equity. The Beale Ciphers represent a triumph of 19th-century operational security. The $60 million fortune is currently trapped behind a wall of math, waiting for someone to identify the correct master text.
We've spent a century trying to force decode the mathematical enigma of sheet number 1. If that code is truly unbreakable, recovery teams have to step out of the archives and start looking at the dirt. The operational security of the text might be sophisticated, but the physical cache itself has no such defense. We are tracking a multi-ton metallic mass, nearly 3,000 pounds of gold, and over 5,400 pounds of silver packed into iron-bound trunks. This grid represents our starting parameters, derived from the decoded instructions in sheet number 2. The cache is buried exactly 6 feet underground, within a 4-mile radius of the historic Buford's Tavern in Bedford County, Virginia. 3 tons of metal sitting inside an excavated pit creates a massive, permanent geophysical anomaly. This target obeys the laws of electromagnetics, not the rules of cryptography. Locating the vault requires a dedicated electronic remote sensing campaign to map the landscape and isolate the signature of the burial site. The immediate challenge is the scale of the Virginia wilderness. Walking the Blue Ridge Mountains blindly is a losing game when the forest canopy is this dense, effectively hiding the ground from view. To see through the timber, we use USGS airborne LiDAR datasets to analyze the terrain at a macro level. The bare earth filter digitally strips away the forest canopy to expose the slope's naked geometry. Here, we hunt for a micro-topographical scar, a settled, unnaturally rectangular sinkhole from the 1819 excavation, measuring 6 by 6 to 10 by 10 feet. LiDAR analysis funnels an entire mountain range down to a few highly suspicious sets of GPS coordinates. Once a topographical anomaly is flagged, the team moves from the sky to the ground for physical verification. The primary tool for scanning the suspected sinkhole is low-frequency ground-penetrating radar, or GPR. Piedmont, Virginia is known for dense orange sisal clay. This soil series is notorious for attenuating and blocking the high-frequency radar waves used by standard detectors. Operators lower the frequency to 250 to 400 MHz, punching through the clay to strike the 6-foot target depth. The radar readout then reveals a high-contrast flat reflector hyperbola, indicating a massive conductivity difference between clay and the buried object. This distinct radar return separates a dense cluster of bullion from natural clay pockets or buried boulders. Even with a strong radar return, the team must confirm the reflector is actually metal rather than a naturally occurring iron slab. This final verification requires a deep-seeking pulse induction detector, utilizing a 1 by 1 meter square frame coil carried by 2 operators. The massive coil size is a tactical choice. It is designed to ignore shallow surface trash like 19th century nails and focuses its electromagnetic field on large, deep targets. As the frame passes over the GPR epicenter, the machine's threshold hum swells into a broad, continuous saturation signal of massive conductivity. Locking on to this deep electromagnetic pulse provides the final proof that the target is non-ferrous bullion, signaling the start of the excavation phase. Even after confirming the metallic anomaly, one final barrier remains outside the realm of physics and sensors. The Bedford search vector often bleeds into property belonging to the George Washington and Jefferson National Forests. Unpermitted digging on federal land triggers the Archaeological Resources Protection Act, leading to asset forfeiture and severe felony imprisonment. Because of these legal risks, recovery teams must restrict their operations to private property. Extraction requires a file non-electronic tool, a formal treasure trove easement contract to legally secure a 50-50 equity split with the landowner. Treating the Beale Ciphers as a remote sensing mission turns a legendary myth into a tangible asset resting in the dirt, waiting for a team with the right sensors and legal clearance to pull it out.